Welcome to this session and the presentation on the dynamics of nutrient allocation from reserved tissues, where we use calcium as a model in dormant reproductive apple buds of 4 commercial cultivars. I'm presenting this on behalf of my group. In the introduction, I want to allude you to the fact that calcium content of cell walls and membranes are normally associated with fruit quality parameters, for example, firmness, internal quality, and sunburn in apples. In apple, the calcium deficiency is synonymous with bitter pit in susceptible cultivars like Brabant, Golden Delicious, and Kanzi that really has great economic implications. Previously, mineral analyses of fruit indicated the importance of the availability of calcium early during the fruit development up to 40 days after full bloom for bitter pit control. We also know that reserved calcium from the various tissues supply fruitlets with calcium up to about 3 weeks after anthesis via the xylem, and this is important for fruit quality. However, information about the calcium supply to the dormant bud and the role of xylem and the contribution towards the final fruit quality has not been quantified in apples or for apples before. Going to materials and methods, we selected 4 commercial cultivars to do the trials. We looked at Brabant and Golden Delicious that are sensitive cultivars and very well known for bitter pit problems. And we compared them to Royal Gala and Trips Pink. Royal Gala is an early season cultivar and Trips Pink is a late season cultivar, whereas Golden Delicious and Brabant are mid-season cultivars. The trials were conducted in the Vryboom region, the Western Cape, South Africa. We looked at bud development during the dormant season, and we selected reproductive buds on spurs on 2-year-old wood for the trial. The trials were conducted in 2012 and 2014, and we are going to report on information regarding results from June to September. We selected 5 dormant reproductive buds per time slot, and the treatments were the genetic differences between the 4 cultivars. Results will be presented as means with standard errors. The analysis was performed on the WD-SEM, the scanning electron microscope, at the Central Analytical Facility in Stellenbosch University. We dissected the buds, and we will be reporting on calcium in the leaf, this section here, the primary xylem when it was formed, as well as the spur section of the bud. We used elemental mapping to quantify the different macro elements, and then it was also possible to show the results as calcium maps that indicated first thing where the calcium was distributed, for example, the leaves and the bud, and also referred to the different concentrations of the calcium in the bud by referring to the different sections of the color chart. Looking at the results, first we wanted to look at the distribution of the calcium as a weight percentage or parts per million between the 3 different tissues. For example, the primary xylem, the leaf, and the spur, and this was presented as 100%. When we look at the Brabant for 2012, and we look at the time frame from June to September, first thing that we notice is that there was quite a high distribution percentage in the spur of between 60 and 66%, and then the rest of the calcium allocation was almost even between the xylem and the leaves. Then we also notice a slight decrease from June to September in the calcium percentage of the spur, and this coincided with a slight increase in the percentage calcium of the xylem. In 2014, again, we see about 60% of the calcium was distributed towards the spur, with the other 2 tissues having similar distributions. And in this case, we saw a slight decline in the calcium percentage of the leaf, with a simultaneous increase in the calcium percentage in the spur, in the xylem, from June to September. Then looking at the Golden Delicious, also for 2012, again, we saw a calcium percentage of about 60% in the spurs, followed by the other 2 tissues. In this case, we only noticed a decline in the xylem concentration percentage from June to September. In 2014, again, we see about a 60% of the calcium was distributed in the spur. And in this case, we see a slight increase in the calcium percentage of the leaves from June to September, with again a decline in the calcium percentage of the xylem from June towards September. If we now move towards the cultivars that are less susceptible for bitter pit, Crips Pink in 2012, we see again starting with a 60% calcium distribution towards the spur in the beginning of the season, but notice quite a big decline from June to September, where we ended with about 46%. At the same time, again, an increase in the calcium percentage of the xylem from 15 to 38%, and also a slight decrease in the leaf calcium percentage from 23 to 15%. In 2014, we saw a similar trend. In this case, the only difference was that the calcium percentage in the spur was even higher in the beginning of the season, with 72%, and that was reduced to 60% at the end of the season. Again, quite a steady increase in the calcium percentage of the xylem. Finally, the Royal Gala, that was also less sensitive to bitter pit problems. In this case, the trend was slightly different, where we see 47% of the calcium distribution in the beginning of June towards the spur was 47%, and almost an equally high percentage was found in the spur, in the xylem of the spur. So in this case, we saw quite a steep decline in the calcium percentage of the spur towards the end of the season. That was mirrored by a steep increase in the xylem for the same period, and no really difference that we found in the percentage of the leaves. In 2014, we don't see the same trend, except for the fact that, again, the calcium percentage of the spur was more or less similar to that found in the xylem, with much less calcium that was found in the leaves. And in this case, the only decline was observed in the leaves. If we now present the data slightly different and we look at the actual calcium concentration, again as a weight percentage of the three different tissues, we start with Braben, comparing the two seasons. We find again that the highest actual calcium concentration was found in the spurs, with similar concentrations in the xylem and the leaves. We saw a significant increase in the calcium percentage of the spurs from June to September in the first season in 2012, but not so in 2014. We also see a slight increase in the calcium concentration of the xylem in 2012, and again a significant increase in the xylem concentration in 2014 towards the end of the season. For Golden Delicious, we see again the highest concentration of calcium in the spurs, followed by similar concentrations in the xylem and the leaf. And in this case, again, in 2012, we found a significant increase in the calcium percentage of the spur, but not so much for the xylem. In 2014, we see a significant increase in the xylem concentration. No, not really. More so in the leaves, but then also in the spur. The actual concentration of the Royal Gala for 2014 showed no significant increase in the spur concentration during the season, but again we found the highest concentration in the spur, followed by the other two tissues. In this case, please note that now we are looking at a much higher concentration of calcium in the buds themselves. We found a significant increase in the concentration of the calcium in the xylem from June to September. In 2014, we saw a similar trend where there's no significant increase in the calcium or change in the calcium concentration of the spur, but we do find a significant increase in the calcium of the xylem during the season. Crips Pink showed a completely different trend, again First, looking at the actual concentration, it was even higher in 2012 than the previous, all the previous cultivars. And in 2014, it was also higher than the Golden Delicious and the Brabant, but similar to what we found in the Royal Gala. In this case, during both seasons, there was a significant decline in the calcium concentration of the spur and the leaves and the xylem. And the leaf calcium concentration there was no significant difference, and neither for the xylem, but there was a significant decrease in the calcium concentration of the spurs. So now we can move towards the discussion. We noticed that the total calcium concentration in the bud tissues were always higher in the Crips Pink and the Royal Gala compared to the Golden Delicious and the Brabant. This may indicate a cultivar difference that we see already early in the season or during dormancy. We found the highest calcium concentration in the spurs, either as a percentage, 40 to 60% in terms of distribution, or as actual calcium concentration that was higher than 1.4%. And this is what we found for all cultivars and both seasons. This indicated a possible role of the spur to serve as a reserve calcium tissue during dormancy. Royal Gala had the lowest spur calcium weight percentage of less than 40%, higher than 50%, and also the highest calcium weight percentage of more than 30% as far as distribution was concerned. Crips Pink and Royal Gala showed a declining calcium distribution trend in the spur and the leaf towards September, and this was mirrored by an increasing trend in the xylem calcium. The calcium distribution of the Golden Delicious and the Brabant was constant in the spur, with varying trends in the leaf and the xylem during the season. The primary leaf differentiation was initiated and established in June for Crips Pink and Royal Gala that was reported before, but it was later, although it couldn't be defined in Golden Delicious and Brabant. This may indicate a possible earlier transport of the mobile elements, for example, calcium, that are dependent on xylem transport for calcium towards the bud. In the two cultivars with the early primary xylem formation in this study, the calcium distribution from the spur and the leaf declined over time, and the percentage calcium in the xylem increased from June to September during both seasons. This confirms earlier signs of calcium in the dormant buds that we recently replied in almonds in 2021, and it also confirmed previous findings of peak calcium concentrations in the xylem after bud break. This was done for apples and kiwi. The calcium xylem distribution increased during both seasons in 3 of the cultivars, Crips Pink, Royal Gala, and Brabant, and this contrasted the decline in Golden Delicious. Unfortunately, the trends were not as clear in the Goldens and the Brabant and didn't always form the same pattern, but both differed quite significantly from the Crips Pink and the Royal Gala trends. This indicated the possible effect of the later development of the primary xylem on the calcium distribution towards the bud. Thus, we can say that the later formation or the presence of the primary xylem in the dormant bud may partly explain the lower calcium concentration and the difference in the calcium distribution between the tissues of the Golden Delicious and the Brabant that was more sensitive towards bitter pit initiation compared to the Crips Pink and the Royal Gala that are less susceptible to calcium-related problems and deficiencies like bitter pit. In addition, the actual calcium concentration could have also been influenced by the presence and the concentration of other macro elements like potassium and magnesium, but we hypothesized that the influence on the calcium concentration would have been similar for all the cultivars. So in conclusion, the spur always represented the tissue with the highest calcium percentage. The actual concentration of calcium was always higher in the spur and of Crips Pink and Royal Gala compared to Brabant and Golden Delicious, and this indicated a higher reserve calcium in the less susceptible bitter pit cultivars in winter. Unfortunately, the trends differed between the cultivars and the seasons. The actual calcium concentration in the xylem was higher in June in Crips Pink and Rolgala, except for Rolgala in 2014, than the Golden Delicious and the Braven buds. This again indicated the potential advantage with calcium in these tissues in the less susceptible cultivars from June. This also showed an increasing trend in the xylem calcium towards September in the bitter pit, in some of the cultivars, the Braven, the Rolgala, and the Golden Delicious, but only for 2012. But unfortunately, at the moment, it gives no explanation for the contrasting behavior that we noticed in Crips Pink. The simultaneous reduction of the spur calcium concentration that we saw and the increase in the xylem in calcium for Braven, Rolgala, and Goldens in 2012 may indicate that reserve calcium comes from the spur, and this is allocated towards the xylem and ends up in the bud, and this needs further investigation. I'd like to acknowledge funding that was provided by the Departments of Horticultural Science and Botany, and also the Central Analytical Facility at Stellenbosch University. Thank you.